Alright, so what is the internet? Who wants to try to describe that? I'm not sure I could actually answer that question.
It's a series of
A series of tubes. Good call. I think you might have gotten the answer right.
What was that?
That was the internet. That series of tubes with the internet, there's all these different computers that are hooked up in lots of different ways. And you're able to, anybody can kind of send any computer a message. As opposed to it being like, Time Warner has a one-way blast kind of connection that it sends, it sends the same stuff to a bunch of different houses at the same time. The internet's about everybody being able to talk to everybody else in the same series of wires or tubes. And then the details of how the internet is implemented, I actually have slightly out of date information on that because it's been a while since I've looked into what do I want to do, or what do I need to do if I want to set up my own colo, or if I want to get access to put a real server in a real data center somewhere. The cloud has changed that somewhat, and we won't really go much into the cloud here. Here we want to talk about the abstractions that are true regardless, whether you're using your computer at home next to your bed and that's your server, or your server is in a cloud somewhere, or your server is in a physical data center in Dallas. Because the thing is, it's pretty much the same no matter what, luckily. Otherwise, it would be really hard to think about. So first and foremost, you think of the internet, you think of the probably most quintessential piece of vocabulary related to the internet, which is the Internet Protocol, or IP. And most of what IP is and what IP does, we don't even really think about at all on a day-to-day basis, because it's all pretty low level. But it does have certain characteristics that we talk about a lot, and one of those is an IP address. So what is an IP address? It's a street number for a computer. So the street address tells you which house is which on a street, and the IP address tells you which computer is which on the internet. Specifically, let's go ahead and say which server is which on the internet. While it's not always a server, maybe you have these load balancers that will automatically round robin to lots of different copies of the same software running on different servers, or maybe it's just your laptop or your phone that's running a server in your house. Whatever it is, it's like a server. And so when we talk about an IP address, it's us, some client somewhere in the world, sending a request to a server at that IP address. So just taking that a little closer to home, what is localhost, or 127.0.0.1? What is localhost from the perspective of me, the client?
Localhost is just your local server within your computer itself. You could be completely disconnected from the internet, and if you're trying to design a web application or whatnot, you could simulate it it's being hosted, but connect it with a localhost.
So if I go on my phone and I type http://localhosts, what is it going to try to talk to?
Talking to the phone itself.
Exactly. It's going to talk to, so whatever client I'm using, whatever the user agent is that I'm using on that client, it's going to try to talk to, if I try to send a request to localhost, if I try to navigate to localhost in a browser, for example, or if I try to submit a form to localhost, it's going to use the same host. It's going to send that request to the same host as the client. So the client's basically sending that request to itself, which sounds like it wouldn't work in a lot of cases, but for most development, it's exactly what you want. Worth pointing out is that sometimes if you have two different servers running locally, you might have localhost :1337, and you might have localhost :1338. That's totally fine. Those can live side by side as long as they each get their own port. On a related note, let's navigate to HTTP localhost 1337, and I get nothing, right? Because I don't have a server running right now. What does it mean if I get rid of this part of the URL? I'm going to try to navigate to localhost on the default port, which is port 80. So that's the same thing as writing this. And similarly, if I want to go to google.com, I can navigate directly to google.com, or I can do google.com:80. And apparently that doesn't actually work. Oh, because it's SSL. But if I go to http://google.com port 80, that does work. So port 80 is the default port. If I don't put a port in my URL, it's going to assume that I want to go to port 80, unless I'm using SSL. If it's an HTTPS URL, then the default port is going to be 443. So there's concept of default ports. We understand that localhost is this special word that means like the client, whatever the client is that's sending the requests, localhost is that client. So you're talking to yourself. Localhost translates to 127.0.0.1, and they are effectively the same thing. And this is mostly by convention. But the reason why, well, I guess, does anybody know the reason why localhost and 127.0.0.1 mean the things that they do? Why does localhost cause the client to point to itself? And why does 127.0.0.1 cause a client to point to itself? And the reason why is going to vary depending on your platform. On a Mac computer, and I think on probably on any kind of like Unixy sort of system, there's going to be this file that you'll oftentimes hear called etchost, even though the etc almost certainly should be pronounced etc. But you'll hear etchosts. This is the etchost file, or the host file, sometimes you'll hear it called. And you'll see, so like localhost, this doesn't answer the question of why is 127.0.0.1 special. I don't really remember, to be honest, off the top of my head, that. But I can tell you that localhost here, this is where we define this special word, localhost, and we make it point to this IP address. So I can actually add my own. I can say that like google.com should point to my own local server. Realistically, you shouldn't need to change this. The times when you would use the etchost file to actually achieve a goal, and not just out of curiosity, would be if you, let's say that you were developing something on an airplane and you needed to test like a third-party integration that did like a single sign-on kind of a thing. So maybe you wanted to do Facebook login. You could simulate something actually talking to Facebook.com and it not really be talking to Facebook.com using the etchost file. You could have it point to some, local IP address, basically. Okay, so that's etchosts. Right. So we've talked so far about what is an IP address. We've started to touch on DNS, which is how Google.com gets translated into an IP address, so that our computers know where to look to find that other computer to talk to, that server. Before we go deep into DNS, I think it might be worthwhile for us to take a little bit of a closer look at a URL together, just to define some terms. So looking at this URL here, let's do http://Sails.js.com. So can someone tell me, what is this part of the URL called that I have selected here?
Protocol?
The protocol, that's right. And then what about this part, or this part, I should say?
Domain?
Yeah, the domain, totally valid. And that's definitely the right answer. Also sometimes called the host, or the host name. Different things define host versus host name differently. For our purposes in Node.js, like if I search URL Node.js docs, and we look at how URLs get deconstructed now in Node, we're actually calling here the host, like if we have sub.example.com, the host here would be the host name plus the port. I forget how this works every time, so this is not something you need to memorize or anything, but just keep in mind that these words host and host name can mean slightly different things. And similarly, John, you mentioned the word domain. Like usually we hear domain in the context of a URL, and we're thinking about what's the TLD, or what's the part of the domain before or after any subdomains, right? So this would be a subdomain, like the sub, and then this would be the domain. And this would actually be the TLD, or the top level domain, the .com part. So you might have example.org, you might have sub.example.org. All of those are different host names. You might have foo.example.info, and you might have like foo.example.sexy, and you might have bar.example.sexy, and just example.sexy, and all of those are also different host names.
I wasn't aware that the port is also part of the host.
I think you'll find that can vary across. So this is using the whatwig URL standard, but you'll see in certain places that'll vary. Hopefully, now that we're coming to a standard on the way that URLs are handled between Node and the browser, this will start to be more like, oh, everyone knows that the host is the host name and the port. But this is, to be fair, has changed numerous times. Not in Node per se, like it's changed once in Node, but it's changed in lots of like whatever the hottest tool is for the last, I don't know, several years. I've seen it go back and forth as far as which one is which. So just be aware. Yeah, be aware when you see host and when you see host name, they may not be the same thing. Over here, you can see there's actually a lot more stuff. So there's the path, which is the part that comes after and including the first slash in the URL. And you can see there's the path and then path name, where like path contains the query string as well. Here they're saying search is like the question mark plus the query string, whereas the query is everything after the question mark. And then the hash, or sometimes known as the URL fragment, is the last part of the URL that's usually only used for client-side stuff. So that's used for things in the browser. There's also auth, which for right now I will leave out of this. There's a standard way built into the concept of a URL of indicating a username and a password. We don't use this for login normally in modern apps. But anytime you hear the phrase HTTP basic login, that's what it's referring to. It's like, oh, okay, if you put this @sign before your host, then you can put like username : password and transmit it that way. And on your server, there's like a certain way of doing HTTP basic auth, which has a certain protocol for like decrypting the username and the password. In the world of SSL that we live in now, where everything is pretty much HTTPS, it doesn't really matter anymore, that extra level encryption, which is, it also wasn't very strong encryption in the first place. And also note that it's encryption and not hashing. All of these are reasons why no one really uses that very much. So, but just so you know, that's what it is. And it's relevant for us mainly when you're talking to the database. So if you're talking to Redis or MySQL, we build these URLs just to have a way of making the information compact, really. But instead of HTTP or HTTPS, you'll see like MySQL or Mongo : / or Redis : /. All right, so let's talk about protocols in general, actually. So we talked just a little bit right now about different kinds of things you could have before the : //. And this little series of letters here, like that's the protocol that whatever this URL represents, like whatever client is connecting to this URL or talking to it, this is the way that you can say right in the URL, hey, the way that I want us to converse from now on is HTTPS. Or the way I want us to converse from now on is MySQL, using the MySQL protocol. The other time you'll see kind of a slightly different meaning of this is like, let's say that there's a link that you can click on in a website and it will open the Slack app on your phone. So maybe in that case you have a URL that looks more, instead of this, instead of HTTP : / I don't know, slack.com mycoolchat, you might see something that looks more like slack : / slack.com mycoolchat. And what that's saying is like, hey, if you click that, your browser is going to be like, hey, do I know about that protocol? Because sometimes apps come along and they're like, hey, I have a protocol that I like to be talked to with, and if anyone wanted to talk to me with that protocol, that'd be pretty cool. You can talk to me like that. So let's see what happens if I copy and paste this. Yeah, so you can see it actually opens the Slack app. You know, it's not actually going anywhere because it doesn't match, and then Slack in their native app, they must have the behavior like, oh, if I don't recognize the URL, just stay where I'm at. Don't show an error message, right? And that's going to vary depending on the app. And an app can even register more than one protocol in a lot of cases. That's gonna always be dependent on like the browser you're in, and then in some cases the operating system that you're on. So it's really, in that case, it's not really as much. It is a protocol. It's a way of like saying, hey, open this deep link in this app. But it's like it's really a protocol that's mostly focused on, hey, open open this part of the app and pull up this state in the app. It's not so much about, hey, we're going to have like an ongoing conversation now. Whereas MySQL, for example, this would mean that, hey, because I'm putting MySQL here, it would mean that, hey, I'm going to try to connect to Slack.com as if it was a MySQL database. And realistically, Slack.com is not a MySQL database, and I'm not even in a MySQL client. But if I was to open up a MySQL client, all right, let's say we want to connect to Slack.com, username, admin, password, we'll keep that a secret, won't we? And the database, data. All right. Test connection is not going to work, probably, unless we're very lucky and Slack happens to be running a MySQL database server on their main domain, which hopefully they're not. So it's hanging, it's not working. This is the client trying to connect over and over again. This URL would look like, here we have slack.com as the host, the username is admin, the password is make anything you want up, and the database is data. So based on what we've talked before about as far as like building connection strings or connection URLs, type that as the URL. So protocol, username, password, and then we saw before in the node docs, we'd have an @ sign. So @ sign, and then if we want to connect to this server, what would we do next?
Slack.com.
Yep, exactly. And we'll just change this protocol to be MySQL. And the only thing that's missing here, because I guess the port number, right, the part that has the colon, right? Like if we wanted to do this on port 3306, which is the default port for MySQL, we might want to make that explicit here.
Yeah.
But a lot of clients, like this client, SQL Pro here, they're smart, and they're able to be like, you know what? And some clients actually do support connecting via URLs. For example, like in Sails, like if you're gonna connect to the database, you specify URL this way. But yeah, like this part here, this port is totally inferable, right? So by default, by convention, MySQL database servers like to live on port 3306. They don't have to. It's just kind of nice when they're always in the same port. So in a lot of cases, this will just work because much in the same way that if we see http://slack.com chat, we're like, oh, it's the HTTP protocol, so therefore I don't need to see written out port 80. I know that that's the same thing, right? I know that that's going to be the same. And similarly, if I'm on HTTPS and I see slack.com, I know that I can type port 443 and that's the same thing. So the client is doing this for us. The client makes it so we can type URLs like this instead of having to type stuff like this. All right, so that's hosts and a little bit of an intro to ports. Actually put a few of the other ports that are pretty common here for you guys just so you'll have seen them. For Redis, it's 6379. For MySQL, it's 3306. For Postgres, 5432. Microsoft SQL, or the protocol itself, I think is called T-SQL. That's 1433. For Mongo databases, 27001. There's actually all these other ones too. So like SSH, like if you want to go on the terminal and you want to connect to another computer, and you want to basically, it's like you're on the terminal of that other computer, then that other computer can run an SSH server, and you can SSH in there, and it'll be just like you're in there typing in the terminal of that other computer. That uses port 22. And then like FTP, so let's say that you were a time traveler and you went back to the early 2000s and you wanted to connect to an FTP server. For that, you would use port 21, unless it was an SFTP connection, in which case you would use port 22. If you were in middle school and you wanted to chat a bunch of your friends in the computer lab, you might use Telnet on port 23. If you were, again, a time traveler and you were going to build your own email server, because that's something you needed to do, because there were no really easy services like Mailgun and SendGrid, etc. yet, you might use SMTP. MQTT, for example, that's another protocol that you could use. It also has its own port that it likes to live on. Let's see what it is. MQTT, you'll hear that come up a lot in the context of Internet of Things projects, which we actually we worked on a project once that I think everyone on this call has worked on, a project that used MQTT in the background. Largely, we were able to mostly not even have to be aware of that though, right? Because it was abstracted away. Let's see, MQTT port. It looks like it's 9001. Oh, maybe not. Oh wow, it's using all kinds of ports, apparently. 1883. Okay, actually just one. 1883. So yeah, that's ports, and that's hosts. So ports are kind of like, you can go to google.com on port 80, you can go to google.com on port 81, you can go to google.com on port 82, and those might all be completely different things. Some of them might be more google.coms. Like honestly, we could deploy a staging environment for one of our apps on just the same URL but a different port, and that would be totally possible. Totally weird, and no one ever really does that because it would violate the principle of doing HTTP requests on port 80 and HTTPS requests on port 443. So that's why you'll have like a subdomain for your staging environment or a different domain altogether, because that way you can it really is more like production, and the more like production it is, the easier it is to catch problems. Yeah, we talked about ports, but let's talk about like what is a port. Basically, as part of the transport layer protocols, you will do things involving ports. It's like a way of having addressability within the same computer. So if every house on the street has a street number and every computer on the internet has an IP address, then each one of those houses in the street might have a different room, and inside of that room, that's like the port number. So maybe it's not a house, maybe it's a condo, or maybe it's a small apartment building, and you might be, or maybe it's where some of us are right now, and we're in Unit B. Unit B is like the port number, and the street address is like the host, like the IP address. So if I'm going to look up google.com, I can do that with ns lookup on the command line, and that'll tell me the IP address of google.com, at least for now, until it changes. And I can like go directly there, and you can see that Google has some smart stuff, just like we do on all of our sites, right? Where if you go to the site, if you go to Sails.js.com with HTTP, it's going to notice and then redirect you to HTTPS. Similarly, they're doing that and checking to make sure that you're not just going directly to the IP address, and they're going to redirect me to google.com. But it still gets me there, right? So that's the IP address. I'm going to it on port 80. I could go to it on port 443. I could go to it on any port. So much in the same way with this is like google.com, or if it's an IP address, the URL works the same way. So the port, right, is like if I have a computer and I have, let's say on my computer I have a web server running that's let's say it's a Node.js sales app. Let's say that's running on port 80 on my computer. That means if I go to localhost with no :1337, just localhost by itself, or localhost :80, I'm gonna go directly to whatever's running on port 80 on my computer. At the same time, I might also have an SSH server running on my computer, which means that if I was going to connect to myself over SSH, let's say I was going to do SSH localhost, or like localhost 22 or 127.0.0.1.22. That's me connecting to this URL, happens to be myself. And if I was actually a server and not just like my laptop behind our home router, then anybody could actually connect to me if I was exposed to the public internet and I had an SSH server running. On the same computer, I might also be running an SMTP server. I might also be running a Telnet server. Might also be running a Mongo server and a Redis server and a MySQL server. And that's all fine as long as they have their own port. So the port really is like the physical address within a computer for some kind of networking activity. If you want to make a request, let's say that I'm a drug dealer and you want to make a request of me, you need to know which room to go to find me. You can't just go knock on the door of the house. I mean, maybe you can, but if I was a drug dealer with many different pseudonyms, you might have different ways of finding me, but the port number will always be the same. If that makes sense. So like 127.0.0.1, that's one way of getting to me. Another way is like localhost. And let's say that I'm exposed on the public internet. Maybe another way of getting to me would be, drugdealer.com, right? And the reason I bring all this up is because there's a different, like when we talk about this port number, it's really easy to be like, oh, it's just like the subdomain, right? It's just like staging.drugdealer.com. And like, it's not. The thing is like this part of the URL and the whole idea of like the host name translating to something, that's part of DNS. And like, that's kind of separate from the real address. Anytime you see anything other than an IP address on this side of the colon of our port number, just in your head, no matter what it is, it doesn't matter how many subdomains it has. It might be like staging.staginger.stagingest.drugdealer.com. All of that just ends up being an IP address at some point. And then the port number is going to be unchanged by that other business. So we talked about the transport layer, which is where the concept of ports gets defined. And I want to come back to that, but I think before we can make much more progress there, we need to talk about DNS. So we talked about how our drugdealer.com example, that gets translated to a URL. If we type that into the browser, and I'll do Sails.js.com and keep this a little bit more PG. Sails.js.com is getting converted into an IP address by using the DNS protocol. So I can simulate the same behavior if I blow this up a little bit, and I do NS lookup, which is a tool that apparently starts just accepting input if you try to use it correctly without any kind of arguments. But I'll do NS lookup help, and that doesn't work. So yeah, so I'm gonna do man ms lookup to get the manual entry. You can also just Google this, and it's probably easier to read anyway. But NSLOOKUP is a program to query internet domain name servers, aka DNS. NSLOOKUP has two modes, interactive and non-interactive. Interactive mode is why I have 3 terminal tabs open right now and why I was getting confused, because it's trying to like do some kind of like call and response DNS party with me, but I just want to do one kind of lookup right now. So that would be me using non-interactive mode. All kinds of goodies in here that you could look at if you wanted. Just remember, it's Q to quit anytime you see this colon in the bottom left-hand corner. All right, so NSLOOKUP, the way that I usually use it is I will be wondering why doesn't something work or what the heck is going on here, and I'll do a lookup and I'll see that, it looks like Sails.js.com is on, or that translates to this IP address 104.26.12.64, and then if I navigate to http:// then it's going to say, oh, Heroku doesn't like me, or this is actually Cloudflare saying you're not allowed to access this directly by IP. And so this is Cloudflare doing some security magic for us automatically. But if Cloudflare was not here, we would be allowed to go directly, just like we saw on google.com. So how does that work for DNS? Yeah. So how does it know when I did this? I typed in NSLOOKUP. Like, what is it doing? How does it know that this is the IP address?
So basically, the DNS is like an actual server itself. It's located somewhere else. And it's usually configured by the internet service provider, but you can always use a custom one as well on the computer. And it's just each time you type in like more of an ASCII text URL, it contacts that DNS server. It plugs you into the right IP address after typing in that URL. So it's like an auto translation, so you don't have to memorize a whole bunch of IP addresses to get to a whole bunch of websites.
Right, totally. If I want to go drive to John's house, I want to be able to look up, I want to be able to navigate there. I want to type like John into my maps, and I just go right there. I don't want to have to like remember 104.26.13.64. So it solves that problem, and the way it does it is it actually sends if I'm in the browser and I'm typing in Sails.js.com, behind the scenes what's happening is that's sending an HTTP request to to whatever IP address Sails.js.com ends up being. But before it can send an HTTP request there, we have to find out what IP address it is. That's where the DNS protocol comes into place. And presumably you have a DNS server, or you're using a service like Cloudflare that you're, I would say, paying for, except that it's free, which is pretty cool. So you're just using a free DNS thing there, and it's like talking to Cloudflare first. It's sending a DNS request or DNS message. I forget if we call that a request or not. It doesn't matter. It sends a DNS message to that DNS server, and the DNS server responds. and says, hey, I know what that IP address is for Sails.js.com, and it's this thing. So that's all part of the DNS protocol. And based on what we know about protocols, if this was using a URL, it might look something like that, right? DNS://. I don't even think it is. Maybe it is. Who cares? That tells you how much it matters in day-to-day usage. And the thing is, it's interesting to care, but you don't have to worry too much about that.
There's also an internet speed tip that a lot of people may not know still, but if you just use a custom DNS, like a fast one, it can speed up that DNS translation and literally make your internet activity faster, or just makes the experience faster because you're waiting less time for that DNS to translate.
Totally, and importantly, John, it'll get around the problem that oftentimes is causing the screwed up DNS stuff, which is like bad DNS cache entries. Like some way or another, it'll be like a website's IP address will end up changing, and it's like whenever we send a DNS request from our laptops or our phones to figure out what URL is this, we're gonna look in our own DNS cache locally first. Like the phone or the computer is gonna be like, hey, I might already know about Sails.js.com. Like I may have been there before at some point in the past, and maybe I have a cache, and then from there it goes up to maybe the neighborhood level or the cell tower level, right? And there's a router there that's saying like, hey, so I heard you like DNS and you have a question. I might have it saved on my deal, so in my cache. So then it might pull it up. Now, unfortunately, depending on how those different DNS cache lookups work, one of those cache entries might be expired, and it could point to the wrong IP address. And so you might find that your browser's like hanging forever because it's actually trying to talk to a different server. So a way you can kind of figure that out is by using NSLOOKUP, actually. It can help sort of like rule out other problems with your internet. But to your point, John, and I'll actually show how to do this, because I go to Settings, System Preferences, and I look for like DNS servers. And this is how my computer knows where to look. It looks like right now I'm actually on AT&T. You can go and find replacement DNS servers for this. The go-to ones for a lot of people are Google. Google has free DNS servers that you can use. And keep in mind, it's not the authoritative source of like, if I'm going to go have my own website like ration.io or Sails.js.com, I'm going to have DNS settings that I configure somewhere like in Cloudflare. And that's where the authoritative answer is on like, hey, if I go to Sails.js.com, what domain or like what IP address does that point to? But there's before you ever make it to that point, you have to have some kind of ideally very, very fast DNS server that you can go to that keeps track of like, hey, has any of that changed, etc. And that's what this is about. So these are the IP addresses of the DNS servers that this computer will try to use. If I wanted to switch that to Google, I could plug Google's IP address or Google's DNS. Google is 8888. Cloudflare is 1111. That's what I use on my phone, for example. Theirs is actually pretty cool. And Google's is cool too. Hopefully everyone's coolness will just make it compete and get even cooler. 1.1.1.1, easy to remember, that's Cloudflare. 8.8.8.8, easy to remember, that's Google. What is a server anyway? It serves up the content that the user is after. That's what a web server or application server would do when you send it a GET request, which is common, and like that's probably the most important thing that a server does. So a server can like return data of some kind or like formatted data, right? And maybe it's the form of an HTML web page that's been personalized in some way for the requesting user agent. Or maybe it is a web page that's always the same damn thing every single time, right? It's a static web page. And maybe in that case, your server could be actually something in a content delivery network, or it could be just like part of S3. It could be very fast because it doesn't need to do any crunching. It doesn't need to do any personalization. The other kind of thing your server might do is it might handle requests to make changes to other systems or the database, or to send an email. So not necessarily, doesn't have to be making changes, but it's things that cause side effects. It could cause some side effect to occur, and it could be some mix. You could get some data, it could cause side effects to occur, it could do whatever. But basically, much like a server at a restaurant, it listens to your requests, it does the thing, and then it responds. At least for an HTTP server. Other kinds of servers like MySQL server, it does something similar, like you send it queries, but you're actually sending it queries over the MySQL protocol, and it maintains a persistent connection instead of HTTP requests, which are stateless. Like every time you send a request, every time you navigate to a website, that's a fresh HTTP request, and when you get the response back, the HTTP request falls to the ground and dies. Whereas the MySQL connection, it's more permanent, right? It's not going to stay around forever, but it'll hang around for a good long time. And different protocols have different levels of permanence. But I guess all that doesn't really tell us what a server is. So we know like how a server behaves, but like what's it like on the inside? A lot of times, and for many, many years, it was always a computer. Now it still is, but it's like a mined computer in a lot of cases. So if I'm on AWS, I'm not necessarily getting a real computer with the server I'm thinking about. I'm getting the facsimile of a computer that's being like projected by this cloud of other computers. So it's like a bunch of people all putting their hands together to take the shape of a human. So that's what most of the time when we talk about servers, like if we're on Heroku, right, and we have a dyno on Heroku, like that Heroku dyno is a virtual server. It's like a representation of a computer that's being simulated by a bunch of other computers. But to the end of the day, it is effectively the right answer. You're right, it is a computer. Sometimes it's pretend, sometimes it's hard and crunchy, but it's always like a computer.
So could it just be a virtual machine as well? Like it's becoming more common for just this cloud-based server environment, just one like super extremely powerful computer basically a computer still, and then just tons of virtual machines running on the same system.
Yeah, so a virtual machine, regardless of whether it's like one physical computer with like virtual machines on there, maybe you have 100 Docker containers or 100 virtual machines in VMbox or whatever on one computer. You could have 100 servers, like logical servers, and that's where you get into you'll hear the terms like logical versus physical servers sometimes. And like the physical server in that case would be your computer, whereas the logical server would be whichever VM is connected to the port of the desired port, right? So you could be like, oh man, and actually this comes up a lot from people in the sales community where they're like, hey, like I want to be real cheap and I just want to have like one physical computer, one physical server, and I want to run a bunch of different apps on it. But it's, if they're different apps, they're probably going to be slightly different, and you probably don't want to do that all in one process. You're going to have just a bunch of different sales apps, let's say. You could do that by running one on each port. And that's fine, as long as by the time it reaches the public internet, you've made it not weird anymore, right? So the weird part is if I go to, and I type in like mycoolsite.com, like I want that to go to the website that's on port 80. Like I don't want my customers to have to know to go to port 81, right? And so I could have some kind of mapping that's like petsmart.mycoolsite.com, and that way maybe I have like a little server that gets in the mix beforehand, or maybe I do this as part of my load balancing, right? I can make it so that petsmart.mycoolsite.com actually goes to the physical server that happens to be located at whatever, and then port 82 or something. So you can totally do that. That's possible. The less that you as an application developer have to think about that kind of stuff though, the better. Sometimes it's unavoidable if you've already started doing a bunch of like customization. But realistically, the vast majority of the value that we can create as developers comes from the part higher level than this in the stack. So us being able to like build experiences, whether that's, even if that's a backend experience, you're building an API, like you're still building an experience and you're not building quite as much of the plumbing. So in this case, like if I needed to have a bunch of things running on a bunch of different apps running on one physical server, the first thing I would ask myself is why? Why is it that I'm going to justify spending very expensive developer hours fiddling with that instead of paying an extra $10 per month for some kind of already baked, fully baked hosted service that'll just let me put my app on a completely fresh server for each client? And there's probably some times where that calculus comes out where you do end up doing that low level stuff, but in my experience, usually you look at the math and you're like, man, it would cost way more money to just roll all this myself and run it on a physical server instead of just like throwing it on Heroku for $7. Yeah, let's talk about what a data center is. A data center is like a place where your server or physical servers, physical computers live. When you hear about applications in the data center, like a lot of times that means that they are older applications that are, I want to say co-located in the data center, but that's just, it's not necessarily always that they're co-located. They're running on servers physically in that data center. That doesn't have to be true. Like you can have a data center whose job it is to run a cloud. Let's imagine you want to create a simulation of a computer. We want to build a software that simulates how a computer behaves, like a VM, right? Same idea as a VM. One way to do that is you have one computer run 100 VMs. But another way to do that is to take some software like OpenStack or roll your own cloud software and make it so that those 100 VMs, instead of being implemented on one physical computer, they could be implemented on thousands of physical computers. And those computers can be cheap as shit and break at any time and it'll still work. And that was like one of Google's I don't know if secrets is the right word or like innovations. It was one of Google's innovations early on with their crawling jobs. So they had like these like containers, I guess, or trailers basically, and they would just fill the fuckers up with like little crappy hardware, right? Crappy computers. But then they would design their software in such a way that like if the job failed, for them it was all jobs, like scheduled jobs, because they're doing indexing, right? Crawling the web. They're just like, they're going to one website, looking for all the links, and then like jumping into the next website from the link. That's all Google or any of them were really doing early on. Plus, thousands and thousands of hours of optimization and improvement on that. But like, I guess that innovation of being able to like split up that, instead of having one really beefy IBM supercomputer, now you have like 1,000 pieces of shit all just like actually able to be more effective. And do the same tasks or run the same or simulate the same virtual machines as if you had 1,000 really great servers, but it's all running on crap hardware. So when you hear the cloud, that's what it's referring to. It's like the cloud means, hey, let's take some crap hardware and let's make it as if we had the nicest stuff in the world. So it's the concept of doing the whole VM thing. It's virtualization, but where there's not just one physical host, it's split across bunches of different hosts working together to simulate that, to simulate those VMs for you. You wouldn't call it mirroring or backing up because it's more like they are completely slaves to the system. OpenStack, it's an open source cloud platform. And you'll see this term infrastructure as a service. That just means like you can use it as like your own AWS. And it has all these parts, and it's been a while since I've looked into what they are, so some of the names may have changed, but they have like Keystone for authenticating, to be able to have your cloud, make it so you can SSH onto individual servers. They have like Swift, which is like you running your own S3. And the way it works, like when you install it, so there's this thing called DevStack, which is faster. Installing this stuff is not particularly easy. And also OpenStack is not the only option out there. There's OneOps. I think a lot of big companies have their own way of doing it if they haven't already kind of succumbed and gone with AWS or Azure or Google Cloud. You could run your own cloud. Like you could make a competitor to AWS and launch it out of your house if you wanted to. You could launch it on like DigitalOcean boxes, or you could launch it on computers in your house. But you do a bunch of setup, and basically you have to go into each one of the computers that's going to be in the cloud, and you have to teach it how to be a team player in the cloud. And so that computer basically gives up all autonomy, right? It sells its soul to the cloud, and it is only there to serve as like a husk that will be all of its motions will be controlled by the cloud. All of the things that it's processing will be it processing it on behalf of pretend computers that are being exposed in the cloud, the virtual machines. And that's what AWS, GCP, and Azure are all doing behind the scenes too. Not with OpenStack necessarily. I don't actually think any of those use OpenStack. They might, but they might even just use certain components. I don't know, but they're kind of conceptually doing the same thing. So a server is just a computer, right? Why can't you just run a server out of your house? Let's say for your startup. So why can't you run the server for your startup as a computer in your house? So John, you mentioned like cost or like uptime basically, or like reliability.
Yeah, and like, needing a special sort of an upgraded internet service like static IP.
Just to talk to the static IP for a second, John, that is absolutely true. But I can tell you from personal experience that at least if you're on Time Warner, it doesn't change that often.
Nice.
So you can kind of rely on it being pretty good for a while. I actually did this for a long time. too long. I did this for one of the first startups that I was ever like pitching investors for. And I think, John, I mentioned this to you a little bit the other day, but I'll repeat it for everyone else. I was on the roof of this place called Fogo de Chao, and they do like Brazilian steakhouse stuff, and it was real fancy. I'd never been anywhere that fancy, and there were all these rich people everywhere, and I was trying to figure out if someone would give us some money to be able to continue to work on this project. And so I was demoing on my phone. I think I was using GoDaddy's built-in, GoDaddy's a registrar, right? So that's where you buy a domain. I think I was using GoDaddy's built-in DNS hosting, their DNS server. And I was having it point to the static IP of my house that I had gone, I'd gone to the terminal and I had typed like, if you're on Windows, it's ipconfig. If you're on Mac or any other Linux system, it's ifconfig. And there's a bunch of crap in there, But eventually, you can dig around and you'll find your IP address of something that works a lot of the times. You can like look for anything that starts with 192, and I think that's my home IP address, but I think that's within my LAN, within the local area network. I don't think that's my real IP. So nowadays, I would just go and I would say like, "What's my IP?" And it would be like, "Oh, okay, cool. That's IPv6. That's why it looks so crazy." But that's just an IP address. Normally, when you see an IP address and it's got all the dots, that's IPv4. But if you see this, it's IPv6. These are becoming more and more common. IPv4 was running out of numbers. There were too many devices. The Internet of Things was getting too thingy. So that's what IPv6 is about. All right, so that's my public IP address. No one do anything nasty to me on the Internet if that ends up on the Internet. And so I was able to plug that in to the DNS config, right? And it pointed to my home computer. I'm skipping a step. I won't go into it. We'll come back to that in a second. There's another reason, right? But if you're able to get a static enough IP address, you can use that. You could use that for your startup server. And it works fine. And it's free because it's just your house. ISPs, like your Time Warners and your Spectrums, they're called now, your AT&Ts, they don't like it when you do this so much because they don't want you like running a data center out of your house. But the fact of the matter is it's the internet and you can kind of do it. So it is possible, but the static IP address thing is totally can be a limitation, and the reliability can be a limitation because on that same time when I was pitching investors on the roof of Fogo de Chao, there was someone in my house that bumped the shelf where the computer was and unplugged it, and suddenly I didn't have a demo anymore. So that's like the main reason. Like, reliability, it's not just like that the hard disk could fail on the computer, right? Because if you have a physical server in a data center, honestly, the hard disk could fail there too. The cloud helps with that because it makes the hardware throwaway. But if you're not using a cloud and you're just using a physical server and that's all you got, then yeah, it's pretty much the same as having it in your house as long as you don't unplug it, as long as the power doesn't go out, as long as your cat doesn't get into it. The static IP is, so if this IP address, when I search like what's my IP, if this thing is always changing, like let's say I'll refresh, it's the same for now, and it's realistically, from what I've seen, it'll be the same for a while, and it won't change until, I don't know, I think sometimes I would see it be the same for months. Back when I was on AT&T Uverse, when I was doing that pitching, and I haven't really spent a lot of time looking at it since, because luckily it's so cheap now to get a server online. You might as well just have it not only be in a data center, but be on a cloud, and better yet, be in a platform as a service provider like Heroku, where you don't even have to like SSH on there. You don't have to think about it at all. So the static IP address, if this number was changing, then my DNS entry that I made wouldn't be right anymore, right? So when I went to, let's say it was Sails.js.com, like if the IP address of my home computer keeps changing, then I can't reliably send people from Sails.js.com to that IP address. The other problem is that when you have a computer in your house, it's not that there's just one computer in your house, right? Like you might have a phone in there, you might have multiple computers, and all of those computers are being routed to by your home router. So whether that's, or it could be a switch to whatever. Your home Wi-Fi router, in most cases, is what is sending traffic to your computer from the internet. So like by default, because most people don't want to be running a data center out of their house, they don't you're not going to have ports. There's not going to be any openness to outside traffic coming in to your house. So if I try to if someone tries to send a request to this IP address that I saw earlier when I searched what's my IP, that's not going to work for anybody, because my router here is going to say, hey, you can't do that. You're not this IP address represented by this router. This home is not available for port 80 internet traffic. But if I was to go into my router settings, right, you look at the bottom of your router, you see that funny little number, that little local IP address, and I was to navigate to it in the URL bar, and I did the little login thing, and it's always admin or whatever, then I would be in and I would be able to configure my router, the physical router box for Wi-Fi. I could configure it to allow port 80 traffic, and I would tell it which computer, which of the devices on my network do I want it to treat as if it was the server in the data center. So if you had two different, let's say that Rachel and I both had different competing apps that we wanted to host from the same house, that's not going to work very well unless we host them on different ports, right? Because then that would still work. But the key is that the IP address, that is permanent. Whatever traffic tries to go to that IP address is going to hit our router, our Wi-Fi router. The Wi-Fi router is going to be do we allow inbound stuff from the public internet? Because it's kind of weird, but if you say so, okay. Then it'll be great, so where do I allow it to? Because there's a bazillion devices, and then that's what port forwarding means. So if you ever hear someone talk about port forwarding, it's saying, hey, dear router, I want you to take all of the incoming traffic to port 80 and port 443, for example, and I want you to just route that to this specific computer, this specific local IP address. So every server out there, every IP address out there on the public internet that we've been talking about so far is what you might call a WAN internet address or a WAN IP address. Let's say that, Madison, you're in a different location right now. Your local internet network or your local area network might be implemented by Ethernet or might be implemented by Wi-Fi, the link layer. But then once you're past that, you get to a router, it uses the IP protocol, and it talks normally over the wide area network or the global internet. It talks over the global or the wide area network to whatever destination you're trying to send your request to. So if you were going to go to blinktop.com, the name of that startup at that time I was talking about, then it would go to my house in South Austin, and it would hit the router, and then the router would be hey, I know that you told me to accept port 80 traffic. Okay, I need to know which local IP address to send it to. So on this local area network, the IP address 1.2.3.4, it might mean something special. And then on this wide area network, there might actually be a real 1.2.3.4 IP address. Whatever your local area network thinks is going to take precedence. So whenever you're doing the port forwarding, what you're doing for your router over here is you're saying, hey, take port 80, take port 443, and then redirect that traffic to this local IP address, to this specific device in my house. TLS stands for Transport Layer Security, or Transport Level, I think it's layer, which you guys might remember from before. Transport layer is connected in some ways to the port, so it's the transport layer, right? So this is the layer of abstraction at which the concept of a port gets assigned. So if you just had the IP protocol, right, and we were just the only language we knew to speak to each other was IP, that would just get us to each other's houses. But because we all know that next layer, that next protocol layer, we know that once you get to the house, not only do you get out of your car, or if you walked, just go up to the front door, you knock on the front door, and then you might say, and you expect that if you see someone unrecognized, you might be able to be like, hey, man, where's Jenny? And then that person could be like, oh, Jenny's in the back, and they could lead you to the back to go see Jenny. So that port, that's the transport layer. Up in the internet, the IP layer, or the network layer, it's called, that gets you to the front door, but it's the transport layer that gets you into the right room. So similarly, it's actually the transport layer that implements SSL. So whenever you see HTTP versus HTTPS, yeah, so it's a different protocol, It is. It's a different application layer protocol, which we'll come back to in a second. But the actual magic of SSL, the encryption that makes it safe for us to be able to use the same password on different sites, although safe is in relative terms, I guess. But like the thing that makes it so that I can send my password and other people in the coffee shop can't see what I sent. The thing that makes it so I can type in my credit cards and that other people in the coffee shop can't see my credit card number. Or, the other people on the airplane, the other people connected to the same Wi-Fi, snoopers in the middle who happen to be able to get access to the wire where all this is running through. If you have SSL, it prevents man-in-the-middle attacks. So SSL is all about, and when I say SSL, TLS, HTTPS, I'm talking about generally the same thing. Though there are slight distinctions in what all those different words mean, and TLS is probably the most accurate to describe what matters about it, which is that it's encrypting at the transport layer. SSL, TLS, HTTPS, it's all kind of the same for our purposes, okay? And I should say that HTTPS, you are implying that, hey, this is like SSL for the HTTP protocol. Similarly, like FTP. So if I was going to go and download an app called FileZilla, 2011, I was making an app to I needed to fetch TV listings, right? And I wanted to fetch captions information too. But I wanted to know, like, the Austin demographic, or the Austin, I guess, audience, what's going to be on channel 2 Fox? What's going to be on channel 3 ABC? This was a time when TV was more important. When I was, the way at that time, which was an older time, to get access to the files that had this information, they would change them out daily, and they existed on an FTP server. So I could connect to that FTP server with FTP : / but I could also use SFTP : / and if I was using SFTP, that was going to do FTP, but over SSL. It's secure FTP. And similarly, if I type in HTTP today, I can do that, or I can go HTTPS. And if I put HTTPS, it's going to communicate via HTTP, but over SSL. So it's the same idea as if you wanted to make a phone call to someone and you wanted it to be encrypted to where no one could snoop in and listen in on your phone call. You would want to encrypt the line, scramble it, right? That's what SSL is doing for us. So in order for SSL to work, you can learn about how SSL works in a lot of different ways, and then you can relearn again because it's kind of complicated and you're going to forget repeatedly for your entire life if you're me. But what's important to remember about SSL is that it uses this cryptography magic, and in order for the cryptography magic to work, there is a key point or a key requirement. So when you buy a new Mac, your computer comes with a browser pre-installed, Safari, right? And Safari, and I don't actually know, to tell you the truth, whether it's in Keychain or if it's in Safari, the browser itself. But somehow, right, on your computer, you've got a certain set of public keys for valid certificate authorities, they're called. And these public keys are out of the box how you, as a user, can just go to any HTTPS website and you can open it up and it works. What's actually happening behind the scenes is that your computer, right around that same time, or I guess right after it's done the DNS thing, it's figured out what IP address it's going to talk to, and then it's like, hey, you know what? This is an SSL connection, so I need to do something securely. So I'm going to talk to this IP address, but I'm going to do so in a way where no one else can snoop. So it's not going to talk directly to that server. I will eventually, right? But it's also going to talk to what's called a certificate authority, which is this man in the middle, who we hopefully trust. And I don't know whether or not you can actually trust the men in the middle or not, or the women in the middle. They're not really humans at all, actually. They're entities, usually like VeriSign, etc. I think that Google actually runs their own CA now, just like they have their own browser. I don't know whether Apple has their own CA or not. It's interesting stuff. You don't need it on an everyday basis, right? But the important thing to understand about SSL certs is that there's this CA involved, And whenever you, as a person that's building a website or an application, you're going to have an SSL certificate that basically legitimizes your website in the eyes of this certificate authority. And I say website, could be an app, whatever. It legitimizes your server, let's say. So that SSL certificate is this cryptographically signed thing that is composed of the of information about the certificate authority and information about you, the website provider. So Sails.js.com, for example, we have an SSL certificate so that you're able to go to https://sailsjs.com. And not only do we have an SSL certificate, if you try to go to http://sailsjs.com without the SSL cert, we're going to redirect you to the SSL version of the site. And that's just a good best practice because, for one thing, it makes it look better in the browser. You got this nice little lock. It looks real secure. But what's happening as well is that if I'm on HTTP, it's like anything. If I try to sign in, like we don't have a login on this website. Let's try Flagship though, because we do have a login there. So if I was to type in my password here, no one look. That password, if I was to log in with it, and well, this isn't actually going to send. Well, it did in this case because this is an older site and we didn't implement that. But let's say that it's like hi@example.com. This is sending a request that includes the password, right? If this was not secure, if I was sending this over HTTP, then this password would be snoopable by anybody else in the coffee shop that I'm in right now, let's say. Or same thing for any credit card numbers I typed in or any other information I sent would be visible. Not just to the other people in the coffee shop, but to my internet service provider and all of the different parties involved in fulfilling that internet request I'm making. Okay, used to back in the day, it was like, if I was advising people, I would tell them, okay, so an SSL certificate is going to run you like $100 a year-ish. Any of the folks who will sell you a domain will pretty much sell you an SSL cert, and they'll still sell it to you. Most of them, they'll make it seem like it's important, like you need it, and that it's not something that's free. However, if you go on Cloudflare and you make a new Cloudflare account and you use Cloudflare as your DNS and all of the other kind of cool stuff that Cloudflare does, then you can actually just go in there and I'll pull this up. So in here, this is Cloudflare. We have DNS. We have only two very simple DNS records here, and then if I go over to SSL TLS, Transport Layer Security, you can see there's all kinds of fun modes that you can use to work with SSL here. Here we have it on flexible. You always use HTTPS. So there's this setting. If you go into the SSL thing, and it has moved around over time, but there's right now at this particular point in time, there's a little thing that says Edge certificates, which sounds confusing. I think it's just referring to that, hey, like, if you're on your phone and you want to go to this website like checkin.com, the certificate that your phone uses to get a solid SSL connection to Cloudflare, that would be the edge. Like, it's on the edge of the internet, if that makes sense, from the perspective of Cloudflare. Like, Cloudflare is like right up there up front talking to your users directly, and they're intermediating your server. So that's why it's talking about the edge. Anyways, there's this little checkbox here called Always Use HTTPS, and this thing's awesome because you can just turn this on and it'll automatically redirect requests for you. This is handy, especially if you're going to turn on in the Sails framework, if you wanted to turn on the secure cookies option, which you should, absolutely. This helps make sure that even if somebody really wants to go to http:// of your website, like, they're going to get redirected back automatically to the SSL version. And that way, if they are logged in and someone's snooping on the local coffee shop Wi-Fi and trying to just see what they can see with Wireshark, they're not going to be able to get your password the first time you log in, and they're not going to be able to fixate on your session in your cookie. Like, every time you send a request to a website, when you're logged into that website, like right now I'm logged into Cloudflare, my browser is automatically sending a cookie identifying my session. And that's how it knows that I'm logged into Cloudflare. If somebody else was able to steal that session ID or that cookie, they would be able to pretend to be me, and they would be able to do things as if they were me. So SSL also prevents that problem. The thing that won't prevent, and the reason why you want to turn on the secure cookie option in Sails or whatever equivalent you're using, is because that secure cookie option makes it so that if by whatever reason, let's say that I copied and pasted this URL and I got rid of the I got rid of the S, right? That first time I would send the request, I would reveal my cookie briefly. Right, so even though it redirected me right away, there was that brief flicker of a moment where my cookie was actually exposed to anyone who might be paying attention on the local Wi-Fi network, right? You guys downstairs could hack into my shit. So instead, you want to not do that. So if you turn on the secure cookies option in Sails, then anytime when Sails, whenever you get counted as logged in, whenever it sets the cookie, it says, hey, you're logged in now. That cookie gets set with a secure option, and then if it has the secure option turned on, then your browser will refuse to send the cookie unless you're on an HTTPS URL. So that kind of solves that one little last problem, basically, where you might inadvertently reveal your cookie.
A lot of times those hackers use something called like a packet analyzer, and they just do packet capture to intercept, pick up that data.
Totally, and if you're one example that I'm aware of is Wireshark. There's other ones, but this particular one, I've used it before. It's like an app. You just install it, and then you can kind of see everything going on whatever network you're connected to. And ideally, you're not only capturing the packets, but if you're gonna inspect them, you need to re-throw them so that everybody thinks that everything was fine, right? The weird thing about Wi-Fi and Ethernet is that you can actually see all network traffic on there. It doesn't matter. So if we're all connected to the same Wi-Fi network, anything that any of our computers are doing is visible and can be looked at. So that's without SSL, you basically have no privacy, at least on that at the link layer on that local network. So what is Let's Encrypt? So Let's Encrypt is this whole thing that I don't remember well enough right now to be able to explain the history of it and everything, but it seemed like circa 20 to 2017, somewhere in there was there started to be widespread adoption of Let's Encrypt, and I think around then is when Cloudflare implemented free SSL certificates by default. So what Let's Encrypt is doing behind the scenes is it's like a protocol for grabbing a new SSL certificate on a regular basis, and so if you're going to roll your own Let's Encrypt implementation, you're going to have to do some work, and I think there's actually some chronologically based maintenance work that has to happen. The good news is that in Cloudflare, for example, they implement free SSL certificates using Let's Encrypt. So this is another one of those things, much like the cloud. We don't have to fully understand how AWS is working behind the scenes. We don't have to understand how OpenStack is working behind the scenes. We just have to understand how to use AWS or set up OpenStack, and then we can get this nice abstraction of a cloud. Similarly with Let's Encrypt, we don't need to know the details of how Cloudflare is doing this Let's Encrypt thing behind the scenes. From our perspective, it means that we get a free SSL certificate. Now we're into the networking stack. So this is, I grabbed this from Wikipedia. There's probably better visualizations. This was just one that I knew that we'd be able to pull up again easily later if we wanted. You can see a bunch of crap in here. Let's start with the bottom, okay? So there's actually one more layer. There's 5 layers to the Internet Protocol stack. The bottom layer is not much of a layer from our perspective as software engineers, but that's the physical layer. So if I have an Ethernet cable coming out of my computer and I plug that into a switch, then that switch is doing some stuff to turn those digital signals, to turn digital signals that it receives from the internet into these analog curly wavy things, right? And aka electricity and stuff. So electricity and stuff, that translation from logical digital concepts, I guess, into hurly-twirly stuff on the analog wire, that's called the physical layer. So whatever is taking it and actually generating those analog signals, the electricity, that's the physical layer. So one layer up from that, the link layer is talking about Ethernet versus Wi-Fi. It's the reason why with Wireshark or a tool like that, a sniffer, you can go on the Ethernet network or the Wi-Fi network and you can see everything that's bouncing around. Why that's the right implementation and the way that it is, I don't really remember. Plus, it wouldn't matter at this point because at this point it's so widely adopted that changing Ethernet is a whole big thing, right? Not that it's impossible, it's harder. So anytime you hear about Wi-Fi G or like Wi-Fi N and all of that, those are like the next iterations of the Wi-Fi protocol, and it's a link layer protocol. So its responsibility is to be able to take internet layer or aka network layer packets and to be able to deliver them to the appropriate device on some local area network. So luckily, you really don't ever need to think about the link layer too much, other than from like a IT networking world, right? Like, so if we were all going to go set up giant office buildings, we might care a lot more about the link layer stuff. Or if we were going to set up printers, we might care more about the link layer stuff. The link layer stuff is where you have things like a MAC address. And that's identifying the physical device on the network. And it's like a permanent address, or mostly permanent. The internet layer, this is where you have the IP protocol. And for our worlds, like pretty much always the IP protocol for the internet layer or the network layer. Okay, and that introduces the concept of these packets. So when we talk about layers, like it's kind of like a letter that you put in increasingly bulky envelopes. So like if I was going to send let's say they're going to send an HTTP request to google.com, or we'll leave the DNS part out of it. We already know the IP address of google.com, and we just want to send an HTTP request to that IP address. So we'll build our HTTP message, this request. We'll build it as a string. Every one of these things is at the end of the day a string, just like everything in life and in nature. And not in like the context of string theory, although maybe, but more in the context of like a string of letters. Any data can be represented as a string, right? Even a JPEG is like a string of 1 and 0s, let's say. So anyway, so an HTTP message is it's a string, you know, it looks a certain way. It looks kind of like, we'll just pick any of them. All right, so it looks something like, if I go copy, there's a way in here to get the actual raw request. Every HTTP request is a string. So then if we take that string and we like wrap it, imagine taking a letter and putting it inside of an envelope, then that's so that first layer, the application layer, was our HTTP string. Then we take that and we give it like a prefix and a suffix, maybe, right? Depending on the protocol it works. That's you stuff it in the envelope in different ways, depending on what kind of envelope it is. If it's a TCP envelope, we stick it in there in a certain way. And now we've got a TCP envelope with an HTTP request inside of it. So then that's good, because now we have a concept of like which port it is, and like under the covers, when you make an HTTP request, it's actually doing multiple calls, right? It's doing multiple TCP messages. It's saying like send or something, or ACK, and it's talking back and forth, and it's sending all these crazy things, and so that it creates a connection, a persistent connection, and then at the end of the HTTP request, it kills the persistent connection. Why it does that, I think there's some good reasons. I vaguely remember something about like needing the connectability at the transport layer, like just so that you have the potential for an HTTP request to be really big. So let's say you're uploading a 1 terabyte file, like that way, since TCP is a persistent connection, you have a way of like leaving the connection open just to keep flinging bytes, right? You can just fling like gigabytes and gigabytes of shit on that same connection. UDP is another option that's used like mostly by games, I think, and other kind of, I guess, higher performance use cases. And UDP is stateless. It does not provide the abstraction of a connection. But all of these are really just ways of stuffing application layer requests into different envelopes. Okay, and then at the network layer or the internet layer, you do the same thing again, except now, luckily, there's fewer kinds of envelopes. There's just mainly just IP. So like I have my IP envelope, I stuff my TCP envelope inside of it. And then that goes, and that might travel hundreds of miles, right, around the world to some other place. And then in that other place, the router is going to receive your IP envelope, your packet. It's going to strip that part off, and it's going to be like, TCP, I know this. And then it'll be like, which room are you in? Which port are you in, right? Port 80, I know this. And then strips off that envelope, and it's like, oh, hey, HTTP, I know this. And that's where like something like Node comes in. And it's like, hey, I'm running my HTTP server and I receive that request and I don't have to think about the transport layer. I don't have to think about the IP layer. I don't have to think about the link layer. The fact of the matter is, like, in your day-to-day life as a developer, you are very likely to be involved up here at the application layer, like all over the place. You're going to be thinking about, not always be thinking about DNS very often, but you're going to be thinking a lot about HTTP. You might occasionally be thinking a lot about WebSockets. You might be thinking a lot about, you might even be using SSH a lot. This is kind of the stuff that you interact with as a human more often, or through something like a browser. The transport layer, I can tell you in my professional career as a developer, I've needed to think about TCP and work with TCP once. And that was when I was building Skipper, which is a file uploady thing. And that's because it was handling really big HTTP requests. And then certain edge cases were like, oh, someone aborts when they're in the middle of a 500 megabyte upload. Or the connection gets snapped for whatever reason. Like, how do we handle back pressure? How do we make it so that if you're uploading 500 gigabytes that like the server is not holding on to all 500 before it dumps it wherever it needs to go? It's skipping it like a rock, right? It's like, it's looking at it, it gets, the first 10 megabytes of information, then it's like, cool, well, I gotta get it out of here, it's too much. I can't hold all this in my head, and I'm worried I'm gonna forget it, so I send it on through. Maybe I process it first, maybe I convert an MP3, maybe I do a streaming conversion of an MP3 into a .wav file, although you would never do that. But maybe I do a streaming conversion of a .wav to an MP3, right? Maybe I do a streaming compression, so someone's uploading a big crazy image, it's like 2 megabytes, like maybe I'm actually creating thumbnails simultaneously on the fly and I'm like storing those thumbnails in Amazon S3. And then I'm also storing the original image as a compressed zip file, right? Like, so that's when you may need to think more about TCP, is if you're really trying to go low level and build like streaming implementations that need to be able to push back. So like if your server is getting overwhelmed by someone uploading too much stuff at once, you need your server to be able to be like, whoa, hold it there. I don't need all that data right now. That's called back pressure. So if you're going to need to implement custom back pressure for any reason, then you might need to think about the transport layer. But honestly, like, that's pretty much the only time that I've personally ever thought about it. So I'm going to run through this list of vocabulary. What are the layers of the networking protocol stack? How many layers are there in the networking protocol stack? 5. And what are those layers?
A physical layer, the link layer, the internet layer that comes after that, and then the app layer.
The thing that comes in the middle is the transport layer. So just whenever you think internet layer or network layer, think like basically it's IP always. It's just IP. Like it's just IP. And that's the part that's like, if you're gonna build your own AT&T, then maybe you're gonna be like doing a better job of like handling IP level traffic. Or honestly, probably Cloudflare may even be doing some stuff with that. So that's real low level, right? But like above that is the transport layer. And you can remember that it's called transport because it's transport. And that's where the idea of a port gets kind of implemented. What is a web server? Well, so like any server, it's a port dweller, right? It lives on a port. As a web server, its job is to respond to port 80 or port 443 style requests. So in other words, it's responding to the HTTP or the HTTPS protocol. It's responding to those requests in any way. The web server has meant different things over time. For our purposes, if you hear people say web server, there's a good chance they're referring to like something that's doing a little lighter weight work. It might not be doing as much personalization as you see in like a sales app. They don't necessarily mean that, hey, that's the thing that serves your My Account page where you can edit your password. It doesn't necessarily serve like the item detail page on the Amazon.com website. Like, yes, technically there is a web server involved there, or like there's something playing that role, but that's where that word application server, which is starting to be a little bit more of a dated word, but when you hear application server or web application server, right, that's like a sales app would be like a web application server. Most apps are like either application servers or web application servers, and anytime you see application server, you can pretty much just think web. Every time you see application server, assume that means web application server, and that's totally fine. Web server is kind of the same idea. The only tiny difference is that when it's a little broader, and it could represent like, hey, this is this completely static site we have that has no personalization whatsoever. That distinction, it really comes from a different time when there was like, you would have a web server like Apache or Nginx, right? And then you would have an application server like Tomcat, right, for Java, or, you know, some other equivalent. And that application server would kind of be like a separate, doing its separate thing. In Node, if you do Sails lift, you're going to start a server and attach it to a port, and you're listening on a port for requests. But if, let's say you're in PHP, you're not going to just like you don't run Sails lift if you're building a PHP app. You're going to have like Apache running or Nginx, and then that server will be actually handling your web traffic, and then it'll be like routing internally be to your PHP app. Maybe it's a Laravel app. So I guess whenever you see a web server, if you're talking to someone that's maybe coming from a different, more of a different time, like they're coming from if they built their chops in the Apache PHP LAMP stack world, like they may be talking about like Nginx or Apache as opposed to like their actual code. So web server doesn't always mean code that like an application developer wrote. It might mean Apache, and then the application server would be the other thing. Would be the thing that you wrote yourself. What's an application server?
More dynamic type websites that are more like an application.
Yep, that's right. You're always going to have a web server. You might have a separate application server in certain situations. Usually from older schools of app development. And what is a DNS server?
It's what you send a request to via an IP address.
Exactly right. Trade in a domain or a host for an IP address. So what's the physical layer of the networking stack? What is it? What languages does it speak on each side? It speaks electricity, and it speaks link layer kind of stuff. It speaks like some kind of digital-ish stuff that the link layer is communicating to it. And on the other side, it's spitting out electricity. What's the link layer then of the networking stack?
The actual method of the connection, the Ethernet, Wi-Fi, MAC addresses.
Yep, Wi-Fi, MAC addresses. What's the other really common link layer protocol?
Ethernet?
Yep, you nailed it. Oh, I just thought of a better example for physical. So, has anyone ever used Powerline before? A Powerline box?
Is that like where you plug in some kind of Ethernet thing into your power outlets and it's able to share it throughout your house?
Exactly. It sends waveforms through the literal power grid in your house.
Yeah.
And apparently that works.
Really strange, but it works.
So if maybe you're just in a place that the Wi-Fi isn't really an option because you have like lead in your walls, or you're just trying to maybe get a little bit extra speed, then you could like plug in a power line outlet into one of your outlets, and then you can basically plug Ethernet directly in the power outlet, and it'll just go into like the power grid of your house. So that would be like a physical layer protocol thing, right? Whereas Ethernet is the link layer, and the physical layer is it like disappearing into the waves of the power line.
Yeah, I've read that a lot of power companies actually can communicate data with the power box in the house, like the meter, and they use just a very similar technique.
Yeah, that blows my mind every time I think about that. But I think it's doing the same. I think it's the same idea. They're basically like using that as a physical layer protocol to send messages or get data. Okie dokie. Then what is the internet layer or the network layer?
That is the layer where the IP protocol happens.
Exactly right. So what is the transport layer?
That's like where it like figures out like where to send you, right? Like the port, the 133.
Exactly. 1337, port 80, whatever. Which room in the house are we going to talk to? And it also does some other stuff. It adds this concept of like persistence to the connection. So if you're going to connect to a MySQL database, like you don't have to reconnect every time you send a query. And the reason for that is that's a TCP-based protocol. So it's able to maintain a persistent connection. Same thing if you're uploading a 1 terabyte file, you don't have to keep reconnecting. It's maintaining an open connection. What's the application layer of the networking stack?
It's kind of like the protocol layer, like browsers and different applications, essentially the ultimate outcome of using the internet.
Yeah, there's a lot of different application layer protocols, and it's like the human languages that exist. It's like living languages today, And then IP is like, the internet layer is just like the ability to like write on paper. You know, like everybody's kind of doing the same thing for that layer. All right, so what's a port?
It's the second bedroom. It's the like specific house. The IP address is a street address.
Right. So the room in the house, and then the house. What in this analogy? What is the house? The host, a computer. So a port is you talking to a specific thing on a computer instead of just talking to the computer itself. What is a host?
That's the IP address, right?
Right. Or the domain that turns into the string that turns into the IP address of it. What specifically is the host name whenever you see it by itself?
Just like the address itself, the domain or IP, but no port attached to it.
Exactly right. And what is a URL? We didn't really get into this, but it's like the full delivery instructions. So if you're Dumbledore and you're like, or the Ministry of Magic, I don't know who writes those letters. I'm not sure.
McGonagall.
McGonagall, thank you. Okay, you're McGonagall, and you're trying to deliver a letter to Harry Potter in like the room under the stairs or whatever, the closet under the stairs. Then like the URL is the universal resource locator that allows you to uniquely like say that, okay, this is going to be Harry Potter's spot, like, and that URL can even contain this weird thing called HTTP basic auth, which is like a username and password as well. So that's kind of like, it's like if the delivery instructions are like type 1234 is the gate code. So what's an IP address?
That's like the series of numbers that is like actually like where you're going when you visit a website.
So it's the actual address of the computer, much like the street address is the actual address of your house. So what's an example of an IPv4 address if I had to like write one out?
It's basically the one with the dots, the old like 4 different places between it, and the amount of numbers can usually kind of vary, but maybe like no more than 3 numbers at a time.
Yep, I think it goes up to 255 if memory serves. And HTTP2 I'm going to scratch off of here because it's not worth it. HTTP2 has wide adoption in some forms, but realistically not a lot of people are using the server push functionality, and most of the magic of HTTP2 is going to be something that gets implemented by people like Cloudflare. So what is HTTP? It's a protocol, hypertext transfer protocol. Hypertext, because it has links. It's hyper. ML was like the kind of, it was like a certain kind of string that would allow you to like make it hyper text with links. And what's the default port for the hypertext transfer protocol? 80. What is TCP?
Transmission control.
What layer of the internet protocol stack does TCP dwell in?
Oh, it's the transport layer?
And given that, what does that mean about its role?
That it's related to the port.
Exactly. That's where the concept of a port arises, is with the transport layer protocol, TCP or UDP. What is IP? Or what layer, let me ask it like this, what layer of the networking stack is IP?
The internet layer?
That's right, the internet or the network layer. And I'll ask you the same question for Ethernet and Wi-Fi. What are Ethernet and Wi-Fi? What layer are they?
Link layer.
Exactly right. This one's a little tricky. What layer would WebSockets be?
The application layer?
That's right. It's going to be at the application layer, and the reason I said it was tricky is because WebSockets is weird in that you start off with an HTTP connection, request. You start off with an HTTP request, and over at some point in the past of HTTP, they were like, it'd be cool if like you could upgrade your HTTP request into something more. And so WebSocket is, to my knowledge, the only time that's ever happened. And so you send this special thing called like an HTTP upgrade, and then it turns it into a persistent WebSocket connection, which is kind of its own application layer protocol that connects over TCP. HTTP and most of the things that we use are always over TCP. What is the Cloudflare?
Domain name service?
I like that definition a lot. That's probably not how they would identify themselves, but that is how I like to think about it as well. They also do the SSL, they do the DNS, and it's free. It's great. All right, so what is localhost? It's on your own computer. You are the client, and you are the computer. It's whatever the client is. Port forwarding, what does that mean? If I wanted to port forward something, what would I be configuring? What device would I be configuring?
Your router?
That's right. I would be configuring my router. I would be telling my router that, hey, it's okay to accept internet requests now from the public internet, no matter how malicious they might be. And when they arrive, I'm going to send them to a specific computer on the local network and a specific port on that computer. So maybe I say that everything coming into my router from outside on port 80, I'm going to port forward it to port 80 of this, or maybe port 1337 of Rachel's laptop. What is a router?
Device that you have in house that make sure that you're getting the pages that you want to get.
That is absolutely true. It is also, and I didn't say this before, so I'm just going to make sure that you guys are familiar with this definition as well. It can also be higher level routers that exist at the neighborhood level, or you'll hear people talk about fiber to the node. I want to run fiber to the node, and like that node that they're referring to is some kind of like cable internet or like ATT box in the neighborhood that has a little router inside of it. So the router is it's like turtles all the way. They go all the way. The internet is really a bunch of routers, you could say. Which are really kind of like computers. It's all just a series of tubes. Anyways, that's a router. Okay. Etsy hosts. What is the Etsy host file?
It's a file on your computer where you can kind of like set shortcuts for where different host names go.
Which
Like
IP addresses they point to. So it's like a little micro DNS server that your computer hits first before it goes and hits other places, except you have to remember to run some special command, and even then, if you're Mike, sometimes you do it wrong. What's WAN stand for?
It's basically just the internet itself, outside of your local network, the wide area network.
And what's the LAN? It's the stuff behind that router. And what's port 21 for? What protocol tends to, by convention, be talked over or talked about on port 21? Via. Talked via.
SSH?
Close. That's port 22. Port 21 is FTP, and if you knew that, I would just say you're definitely a time traveler. All right, this is another kind of a time traveler one. What's port 23? Take your best guess. Telnet. This is the computer lab chat if you're in public school. Port 80, HTTP. I'm not even going to ask, but what's port 443?
SSL.
That's right. It's HTTP over SSL, also known as HTTPS. What is port 6379? What port does Redis use by default? And that's 6379. And what port does MongoDB use by default?
It's 27017.
That's right. The only one I know off the top of my head is, well, if I've been having a very Mongo heavy week, perhaps this one, and then MySQL, just because we use MySQL so much. Redis, it's the kind of thing you don't really have to, well, honestly, when Redis works, you don't have to do a lot with Redis, so like I always forget what the Redis port is every time in between when I'm working with it. So this one is also, I'll just call it out, 1433, that's my SQL server, MSSQL, or T-SQL, or Tedious is also, that's the name of the, TDS is the name of the protocol. Port 1337, what is that?
The Sails app.
Yep. And incidentally, trivia, the original port used in Ryan Dahl's early talks that he recorded for Node.js, which is where it came from in Sails. Port 3000, it's definitely the default port for Ruby on Rails, and it's the default port for Express. What's the protocol?
That's like HTTP, HTTPS, whatever comes before the : //.
That's right. It's somewhere between a language and etiquette for computers. And then last but not least, what is 127.0.0.1?
Your localhost?
That is localhost. Nice work. So this one was a little bit of a review for everybody in different ways. Hopefully we all gleaned something new from it. I definitely relearned some things before I even read this list to you guys. So just to recap, here's what we covered today. We covered the internet protocol stack. We covered basically the series of protocols that we use to talk on the internet. Everything from Wi-Fi, Ethernet, up to IP, up to the transport layer with TCP and UDP, all the way up to the application layer for stuff like the MySQL protocol or the HTTP protocol or WebSockets. We talked a little bit more about protocols even, and about how you can use protocols to open up custom applications. We talked about why you can't run the server for your startup as a computer in your house, or why you technically can, but you might not want to. We talked a little bit more about how URLs are structured and what their various parts are named. We talked about SSL and just kind of a practical understanding of what that means and what you need it for. And then we talked kind of the same way about DNS and how all that works. We didn't much talk about registrars, I just remembered. But the domain registrar is a thing that is like one level above DNS, and it's what you have to buy and sort of like, I guess, rent in some ways to be able to have one of these fancy things. It's not just like 127.0.0.1. So if you want your website to be on a cool hip domain, we got some good ones. Anthem.io. If you wanted a cool hip domain like Anthem.io, available now, you could go register that domain, and then you could like link that domain to a DNS server, and then people could talk to your domain and they would actually get the right IP address, and then they would be able to use your application. So I think that's pretty much the internet. Any questions before we wrap it up?
Yeah, so I was curious of like custom protocols. Is there a specific like place those are registered on the computer?
I don't know it, but there's gotta be. There's gotta be, and it's gonna be on your phone. Or like you'll open it like on a website, you'll click a link and it'll be like, get it from the App Store. But like there's even, and we built this, I think, was it for Proxy, Rachel? I forget. Where like you go, we made a special endpoint that handles like a request, and it checks to, I don't remember what the hell we did, honestly, but we had to do something to make it so that you could like, it would first try to figure out whether you had the app, and then it would go to the App Store if you didn't. Otherwise, it would try to open up like proxy / and open up the app. So anyways, this thing is not just on your Mac, it's also on your phone. Any like client has this capability, or doesn't necessarily, but like usually will. And I don't know where they're registered. I think it's going to vary like per device, per operating system. So on the iPhone, there's probably a place you can go and like go developer mode or whatever, and then see like all of the different protocols that have been registered for each app. And apps can actually register more than one protocol. So Slack could have done like Slack : / and they could have registered like work : / if they wanted it to match their stock ticker or something. All right, guys. Well, I think that's the internet.